forgot often the recording option. Okay, now I can. I think that you can see. Okay. Almost 15 students have joined, and they will also join, I believe, time to time. And at last, I will take the attendance. Or you can give the attendance in your chat box. Everyone can give your attendance in your chat box. Everyone. Give your role, batch, everyone. I want everyone to give your role and batch in the chat box. Because in the last time I forgot sometimes. So it's very tough for me then to collect the attendance. Please everyone give your role and batch your chat box.
Okay, sir.
Okay, next I will check. No problem. At the end I will check. So today okay. Let me mute my students and then start the conversation. Okay, you can also unmute yourself. No problem, but so we are studying our diode also. So today we will see different types of diode, that is quite different in operation. Okay, so this is known as Zener diode. Zener diode, not exactly same the diode works, but this is the purpose of this diode is totally different, and how this works is also different. Okay, so this is Zener diode. So let's see what is Zener diode. So before going Zener diode, the description, I think that you all know this type of IV characteristics curve. Okay, I discussed earlier, probably in the second or third class. I'm not sure. In the probably second class, when we are studying the semiconductor diode or the PN junction diode. So basically, this is the graph. The graph represents the relation between current and voltage. Okay, current and voltage of diode, and especially this graph is for silicon diode. If you can see here, probably this is for silicon diode, and you can see that the silicon diode, because of silicon diode, you can see that the 0.7 volt, the barrier potential. We all know this. The 0.7 volt, the barrier potential, because of the silicon diode. Okay, we all know that, and this graph also gives us the information of the silicon diode in forward bias condition and in the reverse bias condition. This is in forward bias condition, and this side is the reverse bias condition. If we remember or remind that the forward bias means the positive voltage application across the diode, and the reverse bias means the negative voltage applied across the diode. Okay, so we know very well about the positive section, that when the positive voltage will cross the 0.7, at that time the current flow will happen. Okay, at that after 0.7, then the current flow will happen. You see that till 0.7 the value of current is almost zero. But after 0.7, you can see the high rise, the exponential rise of the current. See that exponential rise of the current, because after 0.7 voltage, the diode becomes short circuited, and the across diode it becomes 0.7 voltage source. Okay, so this is the forward biased condition, 0.7 voltage source. So my student, this is forward bias condition. Absolutely, you know everything. But today we are talking about a special kind of diode that doesn't work, or that doesn't have the significance in forward biased. It has the significance in the in the reverse bias condition. I told you, if you remember properly, after finishing this class, you go to my second lecture. I told you that in the reverse bias condition, there hardly any current flow, hardly. Okay, but you see that this is the reverse bias condition. The negative voltage is increasing, but there is no current flow. You can see that. But after a certain limit, after a certain limit, you see that a huge amount of current is flowing, huge amount of current. Though in the negative side, the negative current, but still a huge amount of current flowing, like the positive side. So till today, or till the last class, we discussed till this section. Today we will discuss this section. I said that. I said this previously also. This is a different and special region of diode, or the characteristics curve, where the diode acts differently. So basically, the Zener diode works in this region. In this region is known as the breakdown region or the Zener region. Zener region or the breakdown region. So in this region, the Zener diode basically works. Okay, so what is this region? This region is the breakdown region. So let me clear this everything, and let me have a better. Okay, so you can see from here that this is the Zener region. So till this is the reverse bias region, and this is the Zener region. So today I will discuss about the Zener region, that and how this region works and how the Zener diode works basically. So the diode, that diode works in the Zener region, is basically known as Zener diode. Am I clear? There are two types of diode we studied earlier. One is practical diode, one is ideal diode. We are studying a different types of diode today that is totally different, because practical diode operates in this operation, the forward bias and the reverse bias. But the Zener diode operates in the Zener region. So it is totally different in operation. And also the purpose is also different. The purpose of the Zener diode is also different. We'll see step by step. This is our first class of Zener diode, but inshallah we will take one more class of Zener diode to have a better idea. Okay, and so how this Zener region, or how this huge amount of current flow, how, that is an interesting thing. So if you remember properly, this was the diode symbol. This was the diode symbol, and as it is the reverse bias condition, that's why it is negative, it is positive. So you all know that the PN junction, this is PN junction, in the PN junction, the majority carrier and the minority carrier. I hope that everyone knows that in the PN junction, the majority carrier, if I write majority carrier, the PN junction, it is hole, and the N type, it is electron. Okay, N type, it is electron. For minority carrier, I am writing a small m. For minority carrier in the PN junction, that is electron, and in N type, that is hole. Okay, so the majority carrier in the forward bias, the current is basically for the majority carrier. Please don't draw anything in the screen. In the current, in the forward bias condition, the current basically works for the majority carrier. But when the when the reverse bias or the negative voltage is applied, you see that the connections of minus in the P, plus in the N. At that time, the current, a very small amount of current, you can see that a very small amount of current here, very small leakage current, negative current, that is definitely negative current, is flow, very small, that is negligible. But my student, it has a limit, because we know that everyone, suppose we are being patient, we are having trouble in our life, but we are having patience, but there is a limit. After sometimes we get frustrated, we get depressed, we react to others. So that is the Zener region. So when we increase that reverse bias voltage after some value, after some value, this minority carrier gets so much energy from that applied voltage and starts to flow so when it starts to move or it starts to flow, it collides with other atom. It collides, it hits the other atom. From there much more charge are generated. So at that time a huge amount of current flow, a huge amount of current flow. So basically in the Zener region, when you try to increase the reverse bias voltage so much, after some value the minority carrier will get the energy, and minority carrier will starts to flow. Okay, so when it starts to flow, it collides with the other atoms, and after that it gains more energy, and the more electron flows this side, hole flows this side, so the flow of electron are going on. So the current, huge amount of current flows in that Zener region. So this is the operation of the Zener region. So that's why it is a huge amount of current flows in the Zener region. So this is also known as the breakdown region. Okay, the breakdown region. And the important thing is that, sir, in normal diode or normal doping can make Zener region? No. You need the semiconductor material highly doped. Highly doped means the ratio we dope the p type and n type, the antimony or the boron. It needs to be much more doping. The amount of doping we do normally, we need much more doping. So high doped semiconductor materials basically are converted to the Zener diode. I know that this is all are everything in the theoretical, but you need to understand the sometimes the theoretical also. So you see that it is written here. So I will read line by line, because you need to understand. You see that there is a point. You see that there is a point at this point, and after this point in the reverse bias condition, a sharp rise of current. So this point is basically known as the breakdown point. Okay, the knee point, and this voltage, definitely this voltage is known as the breakdown potential or the breakdown voltage, because it changes the overall condition. Because we all know that in the reverse bias condition, there is hardly any current flow. We consider as zero. But when we make a certain amount of we apply certain amount of voltage in the reverse bias condition, after that when it reaches the breakdown voltage or the breakdown potential, a huge amount of current starts to flow. Okay, so that's why this point is very important, that is breakdown point, and this region is also known as breakdown region or Zener region. Okay, uh, so I discussed why or how the Zener region happens. You see that it is written that as the voltage across the diode increases in the reverse bias condition, the velocity of the minority carrier, I told you that the minority carrier is a very important factor for this Zener region, are responsible for current and also increase. Eventually, their velocity and associated kinetic energy will be sufficient to release additional carrier through collision. That I told you that when it gets more energy, it starts to move and it starts to flow because of its velocity increase, and so it collides with other carriers and other atoms and gets more carrier, something like that. So that's it. That is the process. This additional carrier aids the ionization process, and high valence current is established. Okay, basically the breakdown region is established. So a very important factor is that uh, the VBV. Okay, this is the breakdown voltage. The breakdown voltage, that means that you have to reach that voltage to break down the uh, diode, because before that, if we less that voltage, it will not break down, it will be remain as a reverse bias condition. But when it cross that voltage, that breakdown voltage, uh, then after that the Zener region will happen. Okay, the Zener region will happen. So this is the this explanation is basically how. Okay. So this is the page or slide basically who don't understand that how this Zener region creates. The Zener, I'm also again telling that the Zener region is basically created by minority carriers. We know that they are minor, but when we apply so much energy, so much for potential, after some time it gains the energy, it becomes the velocity, and it starts to move. So it collides with the other atom, and other atom, from other atom it releases electron hole. So when it releases, so the electrons flow starts huge amount. So that is the Zener region, and the operation of Zener diode happens. I think that everyone is clear that how the Zener diode is created. So you can see that this is the practical structure. Basically, there are two types. One is anode, one is cathode. So anode is basically P. My student, anode is basically P, and the cathode is basically N. Anode is P, cathode is N. Always remember that. Anode is N, and cathode is, sorry, anode is P, cathode is N. And this is the symbol of Zener diode. This is the symbol of Zener diode. It's same like diode, same, the diode structure is same, just this. Okay, I'm drawing here one more time. You see that the diode symbol and Zener diode symbol are same. Just we have to two extension of this N terminal. So this is same as P. This is same as N. Everything is same. Okay, my student. And also remember, if I think that you already got it, that Zener diode operation works in reverse bias condition. A reverse bias condition. That means the N is connected with plus and P is connected with minus. In this condition, the Zener diode basically works. Okay, the operation basically works. So these are the symbol of Zener diode. I think you understand. This is the symbol, just the two extension of the thing. And you remember that N is basically known as the cathode, and P is known as the anode. Okay, you see that these are the exact similarity, and how you will, and how, because this is the practical diode. So how you can identify that which one is the cathode and which one is anode. You see a black line or a strip line. The strip line is always cathode. You see that here, strip line. So this is cathode. So this is N, and this is P. Always remember that. In our laboratory class, it will be very interesting. Our first online laboratory class of this course, I'll also discuss this. That when it is the strip, a strip of black line or white line, the strip is also always N, and the other line, other part is P. Okay, so this is the uh, technique to identify the diode in practical life. Okay, uh, now you can see much more. This figure will may help you much more clear idea. You see that as I said, that these are the black strip. The black strip is cathode. So the cathode means N. The cathode means N, and the other is P. You see that? That is the P, and in the N, just this extension, the extension of this symbol, the extension of this symbol. Okay, you see that this is the P and this is the N. So this will help you to identify the diode in practically in the PN everything. Uh, so please, if you didn't give your attendance, please give your role in the chat box and also the batch. Uh, so so my student, the important factors now to come, the application of the Zener diode and how it will works. Okay. So remember one thing, Zener diode is same. Zener diode is same as diode in the forward bias. Same in the forward bias. You see that in this condition also, that's a Zener diode is same as the 0.7 volt, same as like the silicon diode in the forward biased. But as I told you that the Zener region happens in the reverse bias condition. So when it will be connected in the reverse, at that time the main operation starts. But still my students, I said that we have to come at this breakdown potential in the reverse bias condition. In the breakdown potential, the VV, the VZ, the Zener voltage, that is known as Zener voltage, that at that when the voltage across the diode reaches that point, at that time the Zener diode operates. So during this 0 to this region, the diode will like reverse bias, something like that we have done before. The diode will like the reverse bias. You see that in this region, the diode, if we connect here minus and plus, that is the reverse bias condition, the diode will be open circuit. You see that will be the open circuit. But when the voltage will reach as VB, when the voltage will reach as VB, at that time huge amount of current will starts to flow. So the diode will starts to flow. At that time, remember my student, this is a very important understanding. At that time, the diode will work as a voltage source, a voltage regulator. That's why Zener diode is also known as voltage regulator. And what will be the value of the voltage? The value of the voltage will be the Zener voltage, the VZ. So when it will reach that VZ, the diode will work as the voltage source. The Zener diode will work as the voltage source VZ. You see that the same type is the voltage source VZ. That's why it is known as also the voltage regulator. Regulator means it can regulate the voltage. So it starts, but till 0 to VZ or VB, it is open circuit. But when it reaches exactly the VB point, we see that the current starts to flow. So when current starts to flow, we can replace the Zener diode as the voltage source, and that direction will remain the same. The direction will remain the same like the reverse bias condition. So this was the difference. In the forward bias, there is no change. In the reverse bias, when it did not reaches the Zener voltage VZ, it will be the open circuit, something like same. But when it will reach the Zener diode, the Zener voltage, it will become the open source. Okay. Okay. So we can have an example. Then it will help us to understand much more properly. Okay. My students, in this example, you can see that okay, before reading the example, I will unmute my students and tell everyone that is there any problem, or should I are you getting it? Can you give me the feedback, my student? My student, can you
Yes,
give me the
sir.
feedback? Are you getting it, or are you not
Yes,
able
sir.
to
We
get
can
it?
hear you.
Can you getting the topic? Is it clear, the topic till now? My student? My student, is it clear?
Yes. Yes, sir. Can you hear me, sir?
Sorry?
Internet problem, sir.
Okay. Can I move forward? Can I move forward?
Sir, I have one question, sir.
Yes, yes, tell.
Sir, different
Yes,
types,
sir.
sir, different types of diode, like this small diode, large diode, lead emitter diode, or sensor diode. What difference of all of diodes, types of diode?
Sorry, I didn't get it.
Sir, different types of diode, like this lead emitter diode, sensor diode, small diode. What difference is sensor diode or light emitter diode?
Light emitting diode.
Yeah, sensor diode.
You you see that those everything is in the the manufacturing, but the operation is same. There is no change in the main operation. Everything is same. It's all about the the purpose of the application purpose. Light emitting diode, when it gets forward biased, it emits the light. Okay, so Zener diode is also same thing, the same. So the power diode also same things. You will, understand next in the next future courses. So that the operation of the diode is same. Everything is same. But you said whatever the types, that those are not types. Those are the types of manufacturing and application. Okay, so diode, whatever we are studying, that is the the operation, the basic operations are always same for all diodes. But whatever you are talking about, those are the types of application. Am I clear? Am I clear?
Okay, sir, thank you.
And
Okay, sir, thank you.
so why don't you study that what is light emitting diode? If you find any difference, that is totally different. No, the diode operation are same, but the application is different. That diode is applied in a different manner, in a different, you know first in a small light, that is LED. LED is also a diode. LED is also diode. But what is the purpose? The purpose is when it forward biased, it gives us light, light, that particular color of light. That is also LED. Okay. So operation is same. My student, operation is, you don't
Okay,
need to
sir.
you don't need to
Sir, how
tell tell my student, tell.
عبد العزيز وشارك معانا كده.
Yes, please tell my student
You in chat box.
in chat box.
Yes.
Okay. Okay. One student has asked that, sir, what is a Zener diode used for? Okay, you will get the answer this in this example. This is just a voltage regulator, and so different types of diodes, something like this: small diode, large diode. Small diode, large diode. My students, those are the capacity of the current flowing. There is no difference. Light emitting diode, Zener diode, light emitting diode. I already discussed you that. When the current flows inside this, it gives different colors of light. Okay, that is LED. That is LED. There is no difference. And large diode, small diode, power diode, electronic diode, everything is same. The operation is same, exactly same. Just the capacity of current flowing. Just like you will study next that normal transformer and the power transformer, the operation are always same. Just the change of the capacity, how much capacity of current that he can flow or he can allow. Okay, so that is the small diode or and a large diode. There is no difference in terms of operation. The light emitting diode, light emits when it gets the forward bias, it emits that color of light. Okay, so that is the you know thing. If you have any more questions, you can give me in the chat box. Okay, no problem. You can give me the chat box.
Okay.
Okay. Okay, my student, I'm continuing this example. You see that in this circuit diagram, this is a Zener diode. I think that this is the Zener diode, and this is the silicon diode. Okay, this is the silicon diode, and this is the Zener diode. So my student, you see that one more system that means load, one more load, probably a load of R. You can see that on R1, a load is there on. So we have a input voltage of 60 volt uh, plus minus. That means the AC voltage. And let me read the question. Let me read the question. That the network is just designed to limit the voltage to 20 volt during the positive portion and the 0 volt to the negative portion. 20 volt in the positive portion and 0 volt to the negative portion. That means we will give input as 60 volt and 60 volt in the both positive and negative cycle, but in the system output, that means the output is across the system. In the positive cycle, the output should be 20 volt, and in the negative cycle it should be 0 volt. So that is our limitation. That is our told that how it is possible. So that's why to make this 20 volt and 0 volt, we have used a Zener diode of 20 volt. You see that VZ, the Zener voltage is 20 volt. That means when, first of all, now I will ask a question to my one students, because it's required. Okay, who asked the question? Bashar? Farah, Basaf, Absir, Farah, can you hear me?
Sir, it's me, Muhammad Ali.
Okay, Muhammad Ali, you tell me that what is the condition of this Zener diode, my student? Is it forward bias or reverse bias?
Zener diode reverse biased. Why?
How?
Said why?
How?
Why?
Okay, can you explain how we can say that is a reverse bias?
I want to know. Only.
You cannot tell that it is why it is reverse biased. Can anyone tell that what is the condition of this diode?
So the condition of this one is reverse bias because of we can see the input voltage, the direction of the input voltage is going to the resistor. After that, the
The cathode.
this is the cathode. Yes, this is the negative side. I mean, this is the negative side. That's why it becomes to the reverse bias.
Are you agreeing with my direction? The screen?
Yeah, I can see it, sir. It cannot be impossible because of, sir, see it in here we have input voltage, right?
Yes.
So the direction of this in this way, yes. So
And this will be the current flow direction.
yes, this is the current flow. So
when it will enter this diode, it will be positive.
It become negative, sir. Yeah, it become positive. Then so the diode tells that's the negative side.
Is it right now?
Yeah, it's right. It's right.
Okay.
The current entering from the cathode.
Yes, that is the main thing. That now the current is entering from the cathode, or more specifically in the N type, the N side. So we all know that when the N type is connected with positive and P type is connected with the negative, it is the reverse bias condition. So you should know that this is the reverse bias. So basically the diode is in the reverse bias condition.
Exactly. Yes, sir.
Okay. And basically this is for the positive cycle, not negative cycle. Negative cycle, it will be forward biased at that time.
Okay, sir.
Oh, thank you so much. Thank you so much, Amir.
Okay, you're welcome,
okay.
sir.
I continue from here. So basically this Zener diode is negative or reverse biased in the positive cycle. Okay, so we have to tell that, we have been told that the system, across system, the maximum voltage can go 20 voltage. That's why we have put a Zener diode across the system, And now here the Zener diode is working as voltage limiter. It can work as voltage limiter or the voltage regulator. How? You see that, my student, when it starts to flow the current in the positive cycle, my students, I'm talking about positive cycle, not negative cycle, in the positive cycle. Okay, let me go to the bigger diagram that will help us more. You can see that this is the overall discussions. So in the positive cycle, it is 60 volt. It is 60 volt. So so when it starts to flow, my students, the current starts to flow because this is positive, this is negative. So at that time, this will be positive because the current entering this side and the current exiting this side, this will be negative. So now the Zener diode is the reverse biased, and we all know that when the diode is reverse biased, it becomes open circuited. It becomes open circuited. Everyone should know when the diode is reverse biased, it becomes open circuited. Okay, it is open circuited, something like that. But my students, this is the input voltage VI 60 volt. So we just draw a line of 20 volt. We just draw a line of 20 volt. So when it will cross the 20 volt, my student, I told you that this is not normal diode. This is Zener diode. So as you can see, my student, when it is less than 20 volt, when the VI is less than 20 volt, VI is less than 20 volt, you see that this is open circuit, my student, this is open circuit. When it is open circuit, there will be no current flow. There will be no current flow, my students. When it is open circuit, there will be no current flow. At that time, when there is no current flow, the output voltage will be zero because there is no current. When there is no current, there will be no voltage. But when this input voltage VI will cross this 20 volt, and also this silicon voltage 0.7 volt. So when it will cross 20.7 volt, at that time I told you that as it is Zener diode, so when it reaches the Zener voltage of 20 volt, this open circuit will become as the voltage source of 20 volt, my student. This is the significance of giving a Zener diode, because when the output voltage or the input voltage crosses the 20 volt, at that time the Zener diode will transfer from the open circuit to the voltage source, because at that time the breakdown, if you remember the diagram, the breakdown happens in the, so this is the breakdown region. The Zener diode enters into the Zener region. That is the significance of the Zener diode. I think you are clear. But before 20 volt or 20.7 volt, there is the Zener diode is open circuit. The Zener diode is open circuit, so there will be no current flow. So the output will be zero. So when it crosses the 20.7 volt, at that time it will be voltage source, so that the output voltage will be, you know, the system and the this Zener diode is a parallel. So the voltage is 20. So the output voltage will not cross 20 volt. So whatever the increase as the maximum peak voltage is 60 volt, the rest of the voltage will be dropped into that resistance, because the output system is the parallel with the Zener diode. You see that the output voltage is parallel with the Zener diode. We all know that in the parallel branch the voltage remains always same. So that's why it limits the voltage, the output voltage, into the 20 volt. That's why the Zener diode is applied in the output. So the application of the Zener diode is, one of the application is the limiting the output voltage. It can limit. If you apply here 15 volt Zener diode, the output will remain at 15 voltage. If you apply at 40 volt, the output will be remain at 40 voltage. Am I clear? So this is the positive cycle, how it works. Similarly, in this diagram you can see from here, that when it is less than 20.57 volt, you see that 20.7 volt, when it is the less than 20.7 volt, at that time the output is 0, because this generator is open circuit. So when it is open circuit, there will be no current flow. When there will be no current flow, this diode will also open circuit. This diode will also open circuit. So the output, in the output we get 0 voltage when the input voltage is less than 20.7. But my student, but when it crosses the 20.7 voltage, you see that the Zener voltage, the Zener diode can replace as the 20 volt source, and also this diode is 0.7 volt. And as the output is across the Zener diode, so the output will be becomes the 20 volt, because this Zener diode and this output is parallel, and we all know that in the parallel circuit the connections are same, the voltage are same. And my students, what about negative circle? Let me tell you that this is the explanation is given here in the for the positive cycle. Already you got it. But what about the negative cycle? The negative cycle, you, my student, might see this is negative, this is positive, this is negative, this is positive. So that means the current will start to flow like that. So this will be positive, this will be negative. So we can see that this is the reverse bias. This silicon diode is reverse bias. So this will be open circuited. But this will be positive, this will be negative. So this is forward biased. But you can see that this circuit is not completed, because it starts to current flow here. But when it goes to the silicon diode, this is open circuited. So that the circuit is not closed. So there will be no current flow. When there will be no current flow, the system output voltage will be 0. So that's why you see that in the negative cycle, the output, this is the output diagram, the negative cycle, the output is 0. And in the positive cycle, till 20 volt, this is output is 0. But when it reaches the 20 volt or 20.7 volt, the output is fixed as 20 voltage. So this is the output diagram for the positive cycle. But in the negative cycle, there will be output will be the 0, because of in the negative cycle, the silicon diode is reverse bias or open circuit. So the circuit is not completed, just like this. So we get the output when it is open circuit. The circuit is open circuit. There will be no current flow. When there will be no current flow, the system will get the output voltage as 0. So in this way, our condition was you have to make in the positive cycle 20 volt and then the negative cycle 0 volt. So we can see from this diagram that in the positive cycle we get 20 volt and in the negative cycle we get 0 volt. That's one of the application of the Zener diode. You can limit the voltage. You can limit the voltage. If it is told that not 20 volt is 30 volt, at that time we will use the 30 volt Zener diode. If it is 40 volt, we'll apply the 40 volt Zener diode. So, tell.
I am Amir. I have a question, sir. Sir,
Tell.
see it. In this direction,
Yes.
in this direction, how about if the silicon is forward bias? So can we know the voltage of the output?
Okay. Well, let me clear everything. I mean, Amir is talking about, sir. Suppose the silicon is something like this.
Yes.
Am I right?
Yes.
Am I right?
Yes,
Okay.
sir.
On that direction. So, very interesting question. This will be plus, this will be minus, my student, isn't it?
Yes, sir.
So this will be the silicon will be forward bias, isn't it?
Yes, sir.
It will be forward. It will be also forward bias, isn't it?
Yes,
So
sir.
current will flow. Current
Exactly.
will flow. My students, if this Zener diode is silicon based, not ideal. Okay, my students, if this Zener diode is not ideal silicon diode, at that time there is no change in the forward bias, as I already told you. As it is a forward bias, we can replace these as 0.7 volt if it is silicon based. Okay, so at that time the output voltage will be -7 volt if we consider something like that, because you see that the direction minus is upper and plus is low. At that time the output voltage is minus 7 volt. But as it is if it is the practical Zener diode, the zero voltage, at that time, we all know that the diode, when it is forward bias and is ideal diode, there will be no voltage drop. At that time the system has zero voltage output, and all the voltage will be dropped in the resistance. Am I clear?
Yes, sir. Thank you.
Thank you so much. Thank you so much, my students. So today I tried my best to explain you the operation, the difference between the Zener diode and how it works, and showed you one of the example that how it operates and how it can limit the voltage, output voltage. So that is one of the, it is also known as the voltage regulator, my student. Okay. So in the next class, I will try to, give you much more idea about this, show you one or two mathematical problem. So I think that from today's discussion, everyone is clear about the Zener diode. Am I right?
Yes, sir. Yes, sir.
Everyone
Yes,
should
sir.
be clear that what is Zener diode, what is the difference of practical diode and ideal diode. Always remember, my students, one thing, that the Zener diode works in that reverse bias condition, and in the forward bias there is no change. Yes, tell Mohammed, tell. Is there any questions to you?
Yes, sir. I was written in chat box.
You have written in the chat box. Okay, let me check what is the question. I told you that what happens if the Zener diode is forward bias. Zener diode and main diode or ideal diode, there is no change, my student. There is no change. It is when you forward bias, something same like the ideal diode or practical diode. But when it is reverse bias, it is also same. But when it crosses the Zener voltage, a specific voltage will be written. At that time, it becomes a voltage source. Am I clear? Am I clear, Mohammed?
Yes, sir. Yes, sir.
Yes, sir.
Yes. You see this diagram will give you much more closer idea. When it is forward bias, say that it is same as the positive, the normal practical diode. When it is reverse biased, it is also same. There's the open circuit. But when it reaches the Zener voltage, at that time the Zener diode will become as the voltage source. Am I clear? So this diagram will help you much more. So remember two things. My tips to all of you students: Zener diode in the forward bias, same as diode. Zener diode in the reverse bias, same as diode. But when the Zener diode will cross in the reverse bias the Zener voltage, at that time the Zener diode will become as the voltage source. Am I clear now? I think it's clear. Is there any question, my student?
No, sir.
Okay, my students, let me stop sharing and let me discuss, how many students we have. Hasnat have joined. Walaikum salam. 17 students have joined. Okay, 17 students have joined. Let me check the chat box that what are the roles. I think everyone has given role.
Yes.
Please, if you are not given, please give a role in the chat box, please. Everyone give your role in the chat box. Roll 29, batch 29, roll 16, batch 30, roll 4, batch 30, roll 5, batch 30, roll 3, batch 29, roll 8, batch 29, roll 8, 21, batch 29, roll 7, batch 30, roll 2, batch 29, roll 18, batch 30, roll 13, batch 29, roll 4, batch 29, roll 15, batch 29, roll 3, batch 29, roll 7, batch 30, roll 14, batch 29, roll 1, and batch 29 roll 7, batch 30 roll 6, then batch 30 roll 15, batch 30 roll 13, batch 29 roll 8. Is there anyone left? Okay, my student, from today we will start our one of the laboratory class. Okay, as we all know, let me hear first. As we all know that in this pandemic, it's very tough for the what I'm trying to say in the main in the lab we do our laboratory experiment, but as it is right now is not possible from now on. So from today we will start our laboratory class online. I have tried my best to make a excellent, not excellent, informative slide, and also I have managed a simulation software where we will discuss live simulation, and I will discuss. So as we are not getting that opportunity to lab in the practically, I will discuss that how many chapters in the next we will probably after one class we will discuss the transistor. Okay, the next of the thing will be the transistor. The transistor will be also a very big topic. So you have one more courses of electronics. There you will study much more topics. So these are the basic topics, and so today we will start our laboratory course. So I want everyone students to unmute, that if you allow me I will take 10 to 15 minutes break to have my breakfast, because I did my breakfast. After that we'll start our laboratory class.
Okay, sir. It's possible.
Is it okay?
Okay,
Yeah,
sir.
it's okay.
Absolutely okay.
Yeah, positively okay, sir.
Because I have to finish this recording, and this recording needs to post processing, so I cannot start the recording before this processing is finished. Okay, so I
Okay,
cannot
sir.
start the recording for the next class. So that's why I take 15 minutes break. We'll start our laboratory class at 11:45. Am I clear?
Yes, sir.
Okay. Okay, my students, don't go anywhere. Please try to attend. I will try my best to make you understand. And our topic is, today's topic is the IV characteristics curve of diode. Okay, which is related, closely related to today's class also. So thank you so much, my student. I'm ending this class here. After that, I will start the laboratory class. Okay.
Okay, sir.
Okay, sir.
Okay, my student. Thank you so much.